This is the Unit 8 more right triangle application review sheet. And this goes through a bunch of different types of right triangles that we're going to deal with. So let's dive into it. In a right triangle, the altitude drawn to the hypotenuse whoa, okay, so I'm going to clearly have to draw me a triangle if I'm going to follow what's going on here. So there's a right triangle. It says the altitude drawn to the hypotenuse, that's going to be this line right here, divides a segment into two segments, lengths 8 and 2. What's the length of the altitude? Oh yeah, this is one of those problems where I go part, altitude, altitude, part. So part, altitude, altitude, part. 2 over x equals x over 8. Cross multiply and I get x squared is 16. So when I square root both sides, x is 4. All right, Delroy's sailboat has 2 sails with similar triangles. The larger sail looks like that. The shorter sail looks like that. What's the perimeter of the smaller sail? All right, so let's draw me a picture. Got 2 sails. One's bigger than the other one. And it says the larger one is 10, 24, and 26. 10, 24, and 26. And just to help my eyes out, the long side should be the hypotenuse. That's the 26. Now it says the short side of the smaller one is 6. So that's right here. Now this is easily done as a scale factor problem. I see the scale factor is 10 to 6 by looking at the smallest sides on those 2 sails. Well, if I add these sides here up of this triangle, 24 and 26, that's 50 plus 10. The perimeter here is 60. The perimeter here, I don't know. Well, 10 is to 6 as 60 is to that new perimeter that I don't know. So 10p is 360. The perimeter of the smaller one is going to be 36. Now I could also use ratios of the different sides to figure out all 3 sides of the little triangle and then add them up, but this way is a little more efficient. All right, number 3. We've got this right triangle. We've got it's 90 degrees. It told me that was 90, so this is a right triangle. And I want to know which of these things is true, sine, cosine, and tangent. And it's all relative to A. So I don't really like how this looks because that's not how I'm comfortable with it. So what I would do is in my brain, I'm going to take that first one and divide both sides by C. So that moves over. Divide both sides by C. So that moves over. Divide both sides by B. Divide both sides by C. And that helps my brain a little bit better. Now the sine of A, so angle A is right here. And notice this convention if you haven't before. Across from angle A is side A. And sides have little letters and angles have big letters. So the sine of A is opposite over hypotenuse. Opposite over hypotenuse. Note all of these are in relationship to A, so I can go ahead and label this as opposite. This is adjacent. And this is the hypotenuse. So I like this one. But I get nervous on multiple choice questions picking the very first one. So I'm going to keep going. The tangent of A is opposite over adjacent. Oh, that's not right. It's not A over C. It's A over B. The cosine of A is adjacent. That's B over hypotenuse. So that should be B over C. So that's not right. And the cosine of A is the adjacent over the hypotenuse. Sorry, the cosine of A. That didn't write either. If you need to, write down SOHCAHTOA so you can remember that acronym. All right, number 4. In the diagram of the right triangle below, what's the tangent of C? So here's angle C, and tangent is opposite over adjacent. Remember from my TOA, opposite over adjacent. So opposite over adjacent of angle C, the opposite is 2, the adjacent is 3, 2 over 3, 2/3. All right, number 5. We've got a right triangle. There's the 90 degree. 90 degree, that's angle C. It says the sine of A is 3/5. Now, when you draw it yourself, it doesn't always turn out to be proportionally correct, but that's okay because I'm labeling it as such. The sine of A, sine is opposite over hypotenuse, so that has to look like that. What's the value of the cosine of B? Well, the cosine of B is adjacent over hypotenuse. It's still 3/5 choice A. If you were asked to find this side, one way to do it would be to use the Pythagorean theorem, and that would work out great. All right, number 6. We've got an isosceles triangle. These sides are that. That's 68. This is the altitude. What is the length of CD to the nearest tenth of a meter? So what is this right here? Well, it's a right triangle, so this is what I'm looking for. And so 68, this is opposite and hypotenuse. The sine of 68 is the opposite over the hypotenuse. So 20 sine 68 is x, and I'll pull out my calculator. Double check that the mode is in degrees. It is. I pressed mode, and then I'm going to press 20 times the sine of 68. I get 18.54. It said to do it to the nearest tenth, so it's 18.5, or choice C. So number 7 says a person measures the angle of depression from the top of a wall to a point on the ground. So I've got this person on the top of a wall. Here's the wall. Here's the person up here. And they've got this angle of depression. They're looking down here at the ground. And it says the angle of depression is 52 degrees. That's this number right here. And here's this wall. The point is located 62 feet from the base of the wall. So this is 62 feet. How high is the wall? This is what I'm looking for. Now there's a couple of ways to do this. One is to draw your triangle over here. And this distance is going to be x, and this distance is going to be 52. That way works great. But I also know if that's 52, then this is 52 right here, because those are alternate interior angles. So I've got the opposite and the adjacent. That tells me that the tangent of 52 equals the opposite over adjacent. So the tangent of 52 is that, and I need to multiply that number by 62 when I solve for x. So times 62, so 79.356, and it says round to the nearest tenth, so 79.4 on this graph right here, or on this table, it's 79.4. And you could put the positive on there if you want. That's not required. It's understood to be positive. All right, number 8. If a tree 28 meters tall casts a shadow 32 meters long, what's the angle of elevation of the sun to the nearest degree? So we've got a tree casting a shadow on the ground, and it says the tree is 28 meters tall and the shadow is 32 meters long. And so we're looking for the angle of elevation to the sun. Now the sun is up here, of course, casting its light down like this to create this shadow. So this angle of elevation that we're talking about is this angle right here. The angle that from the horizontal that it takes to go up and see the sun. And this is from the end of the shadow, and the end of the shadow is made by the top of the tree. So this is, again, opposite and adjacent. So the tangent of theta is opposite over adjacent, or the inverse tangent of 28 over 32 equals theta. So on the calculator, I say the inverse tangent of 28 divided by 32, 41.2 B. Number 9, a farmer wants to divide a rectangular field in half with a fence as shown below. How many feet of fencing does he need to divide the field? So it looks like all I want is this distance right here. He's going to divide it in half. So how long is that dotted line going to be? It's a rectangle. So I know this is a right angle. Looks like Pythagorean theorem. So this says 192 squared, 192 squared plus 144 squared equals c squared. So 192 squared plus 144 squared is that number. So 57,600 is c squared. And now I need to square root that. So I can square root my answer to get 240 feet of fencing. C. Just a Pythagorean theorem question there. All right, number 10. In a right triangle, ABC, the measure of C is 90. They've got that marked. We've got an altitude right here. AD is 4. Let me label this. AD is 4. DB is 5. How long is AC? Oh, yeah. I remember these questions. So it's going to be the hypotenuse, leg, part. The hypotenuse, leg, part. So this hypotenuse here is 9. So starting at point B and kind of working around, 9 over x equals x over 4. 9 over x equals x over 4. So x squared is 36. X is 6. Number 11. Which set of numbers could be the lengths of the sides of a right triangle? All right, well, I know that it's a squared plus b squared equals c squared if it is in fact a right triangle, and the c, the hypotenuse, has to be the biggest number. So maybe I can't tell what the square root of 40 is. So I'm going to grab the calculator real quick and see the square root of 40 is 6.32. So I'm going to underline the biggest side on all of these. Oh, that was nice. It's the last side on each one. It doesn't have to be the last side, but I noticed they did that. So now it's just a matter of checking them out and seeing. Does 2 squared plus 6 squared equal the square root of 40 squared? Well, the square root of 40 squared is just going to be 40. So let's see. 2 squared plus 6 squared. Oh, that is 40. Okay, so that one looks good. But I never want to stop when I think the first answer is the right answer. So let's keep going. Is 4 squared plus 36 squared the same as 40 squared? All right. So 4 squared plus 36 squared. Is that the same as 40 squared? Nope, not the same. So it's not B. All right, how about this? Is 4 squared plus 6 squared? Is that the same thing as 40 square root of 40 squared? Well, that's 40. So 4 squared plus 6 squared. Well, that's not 40. That's 52. That's bigger, so that's not it. And finally, 2 squared plus 18 squared. How does that compare to 20 squared? So 2 squared plus 18 squared. How does that compare to 20 squared? Not the same. It's less here. So this could be a right triangle right here. A. Number 12, Mr. Gonzalez owns a triangular plot of land BCD, this triangle, with DB is 25, BC is 16. They've labeled that for me. He's going to buy this adjacent right triangle plot of land where AD is 15. What's the total number of square yards in the area of his plot of land? Okay, so I want to find the area, and I remember the area of a triangle is base times height divided by 2. Well, I want to find this whole area here. I know the height is 15. I don't know what the base is because I'm not sure what this is right here. But I can tell that this is a right triangle. So that means that I can figure this side out here with the Pythagorean theorem. So 15 squared plus x squared equals 25 squared. So 25 squared, that's 625. All right, 15 squared is 225. So this is 225 plus x squared equals 625. Subtract 225 from each side, and I get x squared is 400. And now I want to take the square root of 400 to see that that side, x, has to be 20. So that means this distance right here is 20. Which means this whole distance right here is 36, right? 20 plus 16. And then this is 15. So the area is going to be the base, which was 36, times the height divided by 2. So 36 times 15 divided by 2 is 270. And it's square yards there, which is told me. So this is 270. 7. Oh, that's a 9. 270. Okay, now number 13. In the accompanying diagram of triangle RUN, we've got a 90-degree angle here, a 37-degree angle here, and I know this is 21. What is the length of RU to the nearest tenth of an inch? Well, from this reference angle, this side over here is the opposite side, and this side is the hypotenuse. So this tells me it's going to be a sine function, opposite over hypotenuse. So the sine of 37 equals x over 21, the opposite over the hypotenuse. So I multiply both sides by 21. I grab the calculator. 21 sine 37 gives me 12.64. It said to the nearest tenth, so 12.6. A straight string of a kite makes an angle of elevation to the ground of 60 degrees. The length of string is 400. What's the best approximation for the height of the kite? So we've got this kite going here. Here's the kite flying up in the air. There it is. And we've got this string coming off of it, going to the guy holding it on the ground. The length of that string is 400 feet. The angle of elevation is 60 degrees. And we want to know how high is the kite. So we could use the 30, 60, 90 idea, but I'm going to go ahead and work it as a trig function. And we see this is going to be the sine of opposite over hypotenuse. So the sine of 60 is opposite over hypotenuse. Or multiplying both sides by 400, I get this. So 400 times the sine of 60 gives me approximately 350 feet. Number 15. In the picture below, we've got a ladder leaning against the building, 58 degrees. We know that the base here is 6 feet from the side of the building. How far up does the ladder go? So this is opposite over adjacent. So this is the tangent of 58 is opposite over adjacent. Or 6 times the tangent of 58 equals x. So 6 times the tangent of 58, that's 9.6. Says to the nearest foot, so that's going to be 10. Number 16. A ship on the ocean surface detects a sunken ship on the ocean floor at an angle of depression of 50 degrees. So there's my angle of depression. It says the distance between the ship on the surface and the sunken ship on the floor is 200 meters. If the ocean floor is level, how deep is it? So what is this distance right here? That's what I'm looking for. So I've got from this angle, I've got the opposite and the hypotenuse. That's the sine of 50 is the opposite over the hypotenuse. So 200 times the sine of 50 gives me 153.2. And it says nearest meter. So I write 153 in here. 153. Number 17. A worker climbed up a ladder to get on the roof of a building to make some repairs. The ladder was 22 feet long, and it was placed 9 feet away from the building, as shown below. What's the closest to the height of the building? Again, this is a Pythagorean theorem question. I don't have any angles right here. It's going to be a Pythagorean theorem question. So it's going to be 9 squared plus x squared is 22 squared. Or 81 plus x squared equals 484. So then I can subtract 81 from each side, and I get x squared equals 403. And now I'll go the square root of 403 is about 20. B. I knew right off the bat it couldn't be those two because this has got to be the longest side of the triangle right there. All right, televisions are measured diagonally to determine their listed size. Roxanne bought a 40-inch TV that measures 24 inches in height. What's the width of the TV? All right, so here's her TV. It's a 40-inch, so this is 40. It says the height is 24 inches, and we want to know how wide is it. Again, Pythagorean theorem. X squared plus 24 squared equals 40 squared. I know it can't be those because 40 has to be the longest side on that. So 24 squared, 40 squared. So this is 576 and 1600. So I can subtract 576 from each side. And then I need to take the square root of that number right there. 32 inches. X is 32. 32. Nice Pythagorean triple. Number 19. We've got triangle ABC, and C is the right angle. Let's mark it. It's a 5, 12, 13. That's another Pythagorean theorem. What expression can be used to find angle A? Well, cosine. So let's remember this. So, toa. So the cosine is the adjacent over the hypotenuse. That should be 12 over 13. That's not right. The cosine, again, should be 12 over 13. So that's not right. Now the sine is the opposite over hypotenuse. So that should be 5 over 13. That's not right. The tangent is opposite over adjacent. That's 5 over 12. Oh, yeah. That looks good. And finally, let's look at number 20. Number 20 says I've got this shape right here, this 3 squares making a triangle by meeting at their vertices. What's the value of z, the side length of the bottom square? All right, well, if I know this is 400, the area of that is 400. The square root of 400 is 20. So these sides are all 20. If this is a 12, then all the sides of this are 12. So this is a right triangle. So z squared plus 12 squared equals 20 squared. So I've got 20 squared, 12 squared. So this is z squared equals 144 plus, z squared plus 144 equals 400. So z squared equals 256. Z is 16. Double check that was the question. What's the side length of that? Yes, z is 16. And there you go on some application problems for right triangles.